All right, guys, we're on Unit 5. This is day 13. We're going to talk about average rate of change, okay, abbreviated AROC. Average rate of change, guys, is the same thing as our slope formula, if you guys remember from Algebra 1 or from geometry from last year. All slope is change in y over change in x, okay, or also known as the change in outputs, okay, or the change in over the change in inputs, okay, better known as y2 minus y1 over x2 minus x1. In order to calculate slope or the rate of change between 2 points, you have to have 2 points. And a point, remember, is an x coordinate and a y coordinate. And since we need 2 points, we need 2 x's and 2 y's. When we do average rate of change in Algebra 2, they typically will give you your 2 x values. Your job is to find the 2 y values that go with those 2 x values, whether it's from a graph or from a table or from an equation, okay, which we know we can type the equation in our y equals and get the points from our table, okay? So in number 1, it says that a manager wanted to analyze the online shoe sales for his business. He collected data for the number of pairs of shoes sold each hour over a 14-hour time period. He created a graph to model the data as shown below. They want you to determine the average rate of change between the 6th and the 14th hours. So right there, they're telling you your 2 x values. We have an x value of 6, comma something, and we have another x value of 14, comma something. So we have a graph, so we're going to go over to our graph and go up to the 6, and this point on the graph is 6, comma 120. And we have a x value of 14, and the y value is 0, so 14, comma 0. Okay, and so now that we have our 2 full points, we can go ahead and calculate our slope, aka average rate of change. All right, slope is technically only for linear equations. Okay, lines have slope. Because this isn't a line, that's why they call it a rate of change instead of the slope. Okay. All right. So remember, guys, y's to the sky is what I usually tell my geometry kids when I teach them the slope formula. The y's have to be on top. And it does not matter which y goes first. However, whatever order you pick has to be the same order on the bottom. So for instance, if I do 120 for my first y value, and remember that slope formula is subtraction, okay? So minus the other y value of 0. Because I chose to do 120 minus 0, I have to pick the x value that goes with 120, and so I have to choose the same order and do 6 minus 14. Okay. Go ahead and subtract, clean up the top to be 120. Go ahead and subtract on the bottom to clean that up to be a negative 8. And when we go ahead and divide it, we end up with negative 15. Okay. And so what they're going to ask you in more so in Algebra 2 than they do in Algebra is to explain what that means in the context of the problem. So what I do is I go back and I say, all right, what are these y values? So if we go back and we look at what our y values are, it's the number of pairs of shoes sold in the previous hour. So basically it's shoes sold. So on the top here, this 120 that I had, I'm just going to write shoes sold. And then on the bottom, those are our x values. And if you look at the x-axis, that's the time in hours. And so this is really hours. All right, so when we divide them, we get negative 15. We get negative 15 shoes sold per hour. Okay, except negative 15 shoes sold per hour doesn't really make a whole lot of sense. And so we have to talk about what the negative means, because we won't use the negative when we describe. We'll use instead that there was a decrease instead of an increase. Okay, I try to always write my explanation the same way every time. And so we'll go ahead and say between the 6th and 14th hour, there was an average decrease of 15 shoes sold per hour. Okay, and so that is how I always try to write my explanation. I always say between what two X values they gave me, okay? I always say that there was an average, okay, because it's not that there was 15, shoes sold per hour. It was an average of 15 shoes. I always say whether it's an increase or a decrease. So if it comes out positive, you would say increase. If it comes out negative, you say decrease. And then the number that we got in part A, okay, and the label that we came up with in part A. All right, so if you can remember that, it makes explaining the value of an average rate of change question so much easier, okay, if you tend to write it the same way each time. Okay, in number 2, it says which function shown below has a greater average rate of change. So there's your average rate of change. Oops, I wanted to make sure I highlighted that, not wrote over it. All right, so average rate of change on the interval from -2 to 3. And so because that's an interval, we have to remember, guys, that they're giving you your X values. You just have to go and remember to go get the Y values that go with the X values so that you have 2 points so that you can calculate your slope, aka your average rate of change. Remember, only linear equations have a slope, okay? But it is the same formula, so I understand why people will call it a slope. All right, so here we go. They're giving us our 2 X values, guys. We got to go find the 2 Y values. So this is an X value of -2. And so there's one of our points. And here is our X value of 3. And so there's our other point. Okay, we'll go ahead and throw them right into our average rate of change formula, which AKA is our slope formula. Remember, Y's to the sky. And it does not matter the order you subtract your Y's in on top. So I'm going to choose to do the 40 first, and then minus my other Y value of 1.25. Okay. On the bottom, because I chose to do 40 first, I have to do 3 first because 3 goes with 40, and then I'll subtract. Careful, because your X value is a -2. All right, so the minus is from the slope formula, and then your negative, your second negative is from your X value. Okay, go ahead and clean up the top. When you subtract it, you should end up with 38.75. And on the bottom, when you have 2 negatives in a row like that, it actually makes a positive. So that's really 3 plus 2 instead of 3 minus a -2. It's way easier to think about, okay, which is 5. And now that you have your top clean, your bottom clean, and you go ahead and divide, and you should end up with 7.75. Okay, and that is our average rate of change for our table, or for our function f, okay, or f of x. Now they gave us another equation, okay, and that's g of x. And we're going to have to go into our calculator. We're going to go ahead and put this into y equals, okay, and once it's into y equals, we'll be able to go to our table. And in our table, we are looking for the same 2 x values that we had in the first part of this question, okay? So when you go to your table, -2 is going to be paired with 15, and 3 is going to get paired with -150. Okay? And now that we have our 2 points, we can go ahead and calculate the average rate of change, aka our slope formula. All right. Again, it does not matter the order you subtract your y's in. I'm going to go ahead and choose to do -150 first, minus my other y value of 15. And because I chose to do -150 first on the top, then I have to do 3 first on the bottom, okay? And then I'm going to subtract my other x value. Okay? I'm going to go ahead and clean up the top. That's going to be -165. And on the bottom, we have the same thing that we had in the last one. That's actually 3 plus 2, which is 5. Okay? Now that the top is clean, the bottom is clean, we can go ahead and divide, and we end up with -33. Okay, and so now we have our 2 average rate of changes calculated. And the question, remember, asked about which one has a greater average rate of change. And most people will pick the 7.75 because it's a greater number than -33. However, remember that the negative just means that it's a decrease. Okay, so remember that this is just a decrease. So one of these functions is going up, one of them is going down. Okay. And so when we compare which one's greater or which one's least, we only compare the numbers as positive numbers. All right. And so now when we're looking at 7.75 and we're looking at 33, technically 33 is greater. I know that it is negative, but that just means that it's going down. The rate of change is still greater, whether it's an increase or a decrease. Okay. And so we're going to go ahead and say that this one, okay, g of x has a greater rate of change. Okay. All right. We got one more question on this page. So we'll scroll up. And in number 3, guys, it says that the world population was 2,560 million people in 1950 and 3,040 million in 1960 and can be modeled by this function P of t, where t is the time in years after 1950 and P of t is the population in millions. Determine, and here's our keywords so that we know that we're using the formula for slope. Okay. Determine the average rate of change of P of t in millions of people per year from, and here is where they're going to give us our 2 values. Okay. And it says to round your answer to the nearest hundredth. Okay. So again, they gave us our 2 x values. Technically, these are t values, but there is no x in the equation. Hopefully you guys can see t is actually our x and P of t is our y. Okay. And so we need to go ahead and type this equation into our y equals so that we can go ahead and figure out what our y values are from the table that go with our x values of 4 and 8. All right. So go into y equals and type this equation in. Okay. Remember that t is our x. All right. When you go to your table, 4 is going to get paired with 2,742.16 ... Okay. What that means is that I'm using the full decimal, okay, to calculate my average rate of change so that it comes out accurate. Okay. Same thing with this y value. Okay. There are more decimals after this, so I'm going to write ... Just remember to use the full y value when you are subtracting. Okay. All right, so now that we have them, we're going to go ahead and calculate and put them into our slope formula or our average rate of change formula. And we're going to end up with, I'm going to pick the y value of 2,937.28, ... Okay, make sure you use the full y value. You might have to hover over it in your table to figure out the full y value. All right. On the bottom, because I chose to put the 2,937 number first, I need to put the 8 first, okay, and then subtract the 4. All right, we're going to go ahead and clean up the top, and when I subtract those full decimals, I get 195.125, ... And on the bottom, 8 minus 4 is 4. Okay? And now that the top is clean, the bottom is clean, I can go ahead and divide, and I end up with 48.781, ... Okay? And if you remember, on top is the number of people, okay, in millions. So we'll say millions of people. Okay. On the bottom is our time in years. Okay, and so our answer to the nearest hundredth, we're going to round the 8, but we have to look at the 1. And so we're going to go ahead and say 48.78 millions of people per year. And they didn't ask me to explain it or describe it. They just wanted me to find or determine the average rate of change, okay, in millions of people per year. And so we have our answer. Okay. All right, we got a couple questions on the back, and I'll see you guys there.